This is an introduction of geometric series. Okay, so there are three most important formulas that you are going to be using if you are dealing with geometric pattern. The first one is the general one that we already discussed in the playlist, which is the Tn equals to a multiplied by r to the power n minus 1. And this is the formula of the nth term, or sometimes they say the formula of the general term. Right. This formula here basically is used to determine the positions of the terms in the pattern and the values of the terms in the pattern. Right. And then the second one, this was the first. The second one will be the Sn formula, the sum. Remember, series means sum. So the sum formula will be a to the power r, a in bracket r to the power n minus 1 all over r minus 1. This one here is to calculate the sum of nth terms. So if they gave you the sum of nth terms, you can use this formula. Or if you're looking for the sum, or sigma, right? Sigma of geometric. And then the Tn is geometric here. Then you know that you need to use this one. The third one is the sum to infinity. You'll see it with the infinity sign. And it's always a over 1 minus r. Right. This one works for sum to infinity. Infinity. Okay, sum to infinity. And here we also have what we call convergence. Convergence. In convergence, your r basically is in between -1 and 1. So your r is 0, it's plus minus 0 comma something. Ne? You can only have sum to infinity if you have convergence. We'll discuss more about this into the section. Remember, this is just an introductory video. Okay, perfect. And then I need to discuss a few things. Let's say we have this pattern, 2, 6, 18, and so on and so on, right? And then we need to check if this pattern is geometric or not. To check if a pattern is geometric or not, you check by the R, the ratio, which is given by T2 over term 1, which is the same as T3 over T2, which is the same as T4 over T3, which can continue this way until we have Tn at the top, then at the bottom we have Tn minus 1. It's just the ratio between two consecutive terms. The bigger one is on top, the smaller one is at the bottom. So if n is 4, here we're going to have 4. Here we're going to have 4 minus 1, which is 3. There. So this is the general formula of the R. Ne? Sharp. So now, in this case, let's check if this pattern is geometric or not. We're going to firstly do it separately because we're checking, right? So term 2 over term 1. What does that give us? Term 2 is 6. Term 1 is 2. The answer is 3. All right, let's check term 3 over term 2. And then we can see that term 3 is 18, term 2 is 6. The answer is still 3. Therefore, you can see that this pattern is geometric. Therefore, geometric because T2 over T1 is the same as T3 over T2, which is the same as the R. So this R here is your constant ratio. Okay. And then A is just the first term. Ne? After you have verified that the pattern is geometric, you can now conclude that your A is the first term of that pattern. All right. Perfect. And then in this case, I can see that, okay, this pattern here that I'm talking about, this one, right, is divergent. Divergent. Why am I saying divergent? Because it's not, the R is not 0 point something. We can see that R is bigger than 1. So if R is bigger than 1 or bigger than -1, we have divergence. Therefore, here we're not going to have no sum to infinity. You agree? So the sum gets bigger and bigger and bigger as we go. Do you get it? sharp. So it's diverging. There's no number it approaches, basically. You can only have sum to infinity if we have convergence. Right. I hope this video makes sense. Please watch the next video for more details on geometric number pattern. Thank you very much for watching. Don't forget to hit the like and subscribe button. Aluta continua. Tango.